Hello students, welcome to Saraswati classes. Now continuing with the lecture of synthesis of carboxylic acids. Today we are going to discuss another procedure which we are calling the procedure number 4, which involves hydrolysis of carboxylic acid derivatives such as esters and nitriles. Now, it is worthwhile to mention that such hydrolysis reactions can either be acid catalyzed, that is involving the hydronium ion, or they can be promoted using base. That is, we first use the sodium hydroxide dissolved in water and finally work it up to regenerate the carboxylic acid from the carboxylate salt of sodium using hydronium ion. So this basically involves an acyl substitution mechanism which is basically called addition elimination mechanism that replaces any acyl group acyl leaving group with that of a hydroxyl group. Now, in case of synthesis of carboxylic acids from nitriles, one should remember that the Cn minus group is introduced via a SN2 reaction on a alkyl halide, mostly methyl halides, primary halides, okay, and this involves a new C single bond C formation. Okay. So basically, to summarize the whole theory that I taught you over here, it is basically, we can say this is our ester, or this is our alkyl nitrile. The reagent that we are using is sodium hydroxide in aqueous medium, and we follow it up using acidic workup, and this whole procedure is called our hydrolysis, and that leads to the formation of the carboxylic acid. This is our ester and this is our nitrile. Now, as I was saying, that the nitriles are prepared via reaction with alkyl halide. So we will use NaCN, and the mechanism operating over here is a nucleophilic substitution SN2 type that leads to the formation of the alkyl nitrile, which now we can think undergoes hydrolysis in presence of the basic medium, and then worked up with the acidified water to give us the following carboxylic acid. Interesting to note over here is that we have started with a lower alkane, and once the hydrolysis of this CN is done, the carbon count of the final molecule has increased by 1 unit. So we will say carboxylic acid product over here has 1 more carbon than starting material. Alkyl halide. So that is the vital part of this reaction. So whenever you want to increase the carbon by 1 unit, think of using an alkyl halide, introducing a nitrile group using NaCN, and then perform the hydrolysis. That is the base or the acid hydrolysis. Okay. In the next section, we will again talk about another procedure by which we can increase the carbon unit of the chain by 1 unit. And herein we are going to discuss synthesis of carboxylic acid via Grignard reagent. In other words, we will be using a RMGBr with dry ice, that is solid CO2, followed by acidic workup, and we will generate our carboxylic acid. So what do we essentially do over here? We are going to react a Grignard reagent with the carboxylic acid, followed by the acidic workup, as I said. So basically again here the synthesis is going to convert a alkyl halide or a aryl halide to a carboxylic acid while also extending the chain by one carbon. So we will involve a alkyl halide. So basically this is our formation of Grignard reagent, and that is going to give us our CH2 MgBr, which we are going to react with CO2 followed by the acidic workup, and that is going to give us the following carboxylic acid. So the mechanism part here is what? We have a RCH2 minus that is going to react with the electrophilic center of the carbon dioxide, undergoing a nucleophilic attack, which we call as the nucleophilic addition. And then we have this unit being formed in the reaction mixture, where we can see that a new C single bond C bond is being formed, and this, once we treat with the acidic workup, that is the hydronium ion, it is going to take up the proton and eventually lead to the formation of the product. Thanks for listening. So keep visiting Sorosha classes for the retrosynthetic approach of carboxylic acids, which will be the next part of the lecture. This is Dr. Sarkar over here saying goodbye. Thanks for listening. Have a great day.